Hi. So now we have a definite integral. We have been taught to evaluate, and we have these limits here. We have the lower limit as well as the upper limit. So even though we are talking about a definite integral, we have to evaluate. Your first main area of attention is this part here, because if you get something that is wrong here, even if you evaluate for these limits that you have been given here, you won't really get something that is correct. You still get the question wrong. Okay, so what I'll do right now is that I can try to simplify this for myself. Okay, so I can just continue to write this as it's the integral of let's say you're integrating from pi over 4 to 3 pi over 4. Okay, so the inside part, I'm just going to try to simplify it. So the way it's going to come out, I'll explain why I'm saying so. It's because I'm going to write it as the square root of 1 plus cot squared 2t dt. Then I'm going to put a 2 outside here. Where is this coming from? Like, where is this coming from? And why is it coming from that to that? So what I've done here is very simple. I've just said, okay, I have the square root of, I can factor out the 4. I can say it's a 4, then open bracket, I'll say 1 plus cot squared 2t, like that. And one thing that you have to understand about this is that if, for example, if you're looking for the square root of a multiplied by b, you can write this as the square root of a multiplied by the square root of b. And this is very simple. In this case, it so happens that the a is what is a 4 multiplied by the square root of your b, which is 1 plus cot squared 2t, like that. And the square root of 4 is what? Is a 2. That's why I've put a 2 right here. So that is where that is coming from. And it's very interesting. So now, for me to continue to integrate this one here, I can choose to simplify work for myself. I know from trig identities that cot squared theta plus 1 is equals to is equals to cosec squared theta. So it simply means even if I say cot squared 2t plus 1, this will be equals to cosec squared 2t, like that. So this is just the angle, don't worry about it, that's just an angle there. So you can actually now for this to be in a square root, it simply means it's more like you're just saying cosec 2t is equals to the square root of cot squared 2t plus 1. And that's what I'm going to do here. It's just to substitute with just substitute with cosec 2t there. Okay, so here is how it's going to unfold. So this will still be like 2. Then you're evaluating from pi over 4 to 3 pi over 4. Then this will just be, that will turn out to be cosec 2t dt. Okay, so you can actually check the table of integrals to find out what that one is going to be. Okay, to find out what that one is going to be, or I can choose to write it this way. Okay, I can just write it this way. Actually, this one, the solution, when you check the table of integrals, if I'm not mistaken, this would just be equals to natural log of cosec 2t minus cot 2t, like that. Okay, so having in mind that you're evaluating from what you have those limits, which is pi over 4 and to 3 pi over 4. So how you can come up with this one without using the table of integrals is very simple as well. I can just write this in terms of its equivalent trig identity, and I know that that is equals to 1 over sine 2t. Okay, so it's more like you're looking for the integral of 1 over sine 2t. And again, before I go to this, you might wonder to say, where is this 2 going? I am supposed to have a 2 here, but when you integrate this one, it will be divided by what? The derivative of the power, which is what? Sorry, the derivative of the angle, which is a 2. So that 2 cancels, and it cancels with that one there. That's the logic that works there. So this one, you observe that when you come back to this part, just trying to show how you can come up with this one. It's just a matter of doing anything that you're able to do to make it easier for yourself. So this can be written as 1 over sine 2t. I'll manipulate it by multiplying by sine 2t divided by sine 2t. So this, how this one is going to be is like this. It will be the integral, okay? So that will be sine 2t divided by, I'm supposed to say sine squared 2t, but I'm going to write it as 1 minus cos squared 2t. Still dt there. This part here is supposed to multiply with that one so that you get sine squared 2t. Then you know some trig identity that tells us to say sine squared theta plus cos squared theta is equals to 1. So I've just made I've just made sine squared theta to be the sub of the formula. In this case, my theta is 2t. Okay, and that's what you have. Okay, so how does this now continue? Okay, how it continues is that you can use u substitution here, where you're going to let your u be equals to cos 2t. Okay, so meaning your du will be equals to your du is going to be equals to minus 2 sine 2t, like that, dt. So you observe that your dt is just equals to du divided by minus 2 sine 2t, like that. So remember to say our u, we said our u is equals to cos what? Cos 2t. So this will be the integral of, on the numerator I still have like sine 2t divided by, that we say 1 minus u squared. Why am I saying u squared? I've said cos 2t is a u, meaning cos squared 2t is u squared. Then here I'm going to say what is your dt. Instead of dt, you're going to put du divided by minus 2 sine 2t. And it so happens to say this can cancel out with that one. Okay, so hence you have something like minus 1 over 2, then the integral of 1 over 1 minus u squared du. I'll not continue from here. I believe you're able to end that. So what you do here is that you can just break this one down into its equivalent partial fractions. And how is it going to unfold? Okay, how it's going to unfold is like this. This will be like minus 1 over 2. I can choose to write that as 1 over 1 minus u. Okay, 1 minus u. And again, one thing that I observe is that it's actually very interesting, because since I have a negative here, okay, since I have a negative there, I can choose to manipulate what I have there. Okay, so I can choose to write that as a positive. That would be like 1 over 2 to be positive, then that would be the integral of 1 over. So instead of saying 1 minus u squared, it would be u squared minus 1 du. Wow, very interesting. So now, how will this be? This is going to be 1 over 2, integral of 1 over u minus 1, like that, multiplied by u plus 1. That's why I was talking about you being able to break this one down into its equivalent partial fractions. Okay, so it's a situation where you can write this as 1 over 2, then integral of, it can be more like a over u minus 1 plus b over u plus 1 du. Then you just go ahead and complete that one. It's going to take you back to this one. And what you can do is that for this case here that we have, which is also quite interesting, instead of you using cosec as well as cot, you can write this as, okay, I have like ln of, instead of cosec 2t, I'll write this as 1 over sine 2t minus, instead of cot, I'll write this as cos 2t divided by sine 2t. And you go ahead and evaluate. It's simply because when I substitute where there is where there's t with what you have here and what you have here, it's much convenient to use sine as well as cos instead of using cosec and cot. And from there you can go ahead and find your solution. You remember you're evaluating from pi over 4 to 3 pi over 4, and that's how, those are the steps that are needed. I've done everything that's necessary that needs to be done. All that's remaining is just for you to substitute. You substitute this one where there's t there, where there's that t, where there's that t, then again you're going to say minus, substituting this one where there's t here, where there's this t, and where there's that t, and you come up with your solution. You can actually use your calculator here. So that's how you answer that one. Thank you very much for watching, and we'll catch you in the next one.